The importance of the topology and the underlying connectivity of the network at the data link layer is central to the performance of any algorithm and protocol that we use at the data link layer. And especially if you're looking for simulating such a network, the data link layer performance is closely tied to how the network is connected and what topology is being used. In this module, we shall quickly recap about our basic understanding of famous network topologies. Then we'd look at the constraints of wireless networks, especially ad hoc networks, in which the topology is limited. Then we'd look at the relationship between connectivity and reusability of the communication channel. And we'd look at a figurative representation of a relationship between the transmission range and the reusability of the communication channel. The references that I've chosen are Communication Networking and Analytical Approach by Anurag Kumar and others, and Modeling Internet Topology by Kenneth Calvert and others. As we know, topology is the physical connectivity of the devices in the network, including the end hosts and the network and switching elements. These devices and network elements could be connected to each other in various configurations that we call as topologies in other terms, including the star, hub, mesh, bus, and tree. These are easier to manage and have a special relationship with regards to their application, throughput, and other network parameters. The only thing that is common to all of them is that connectivity is implied. That is, all the hosts can reach to other hosts using the connections. The wireless networks are different in the sense that their topology and connectivity are greatly affected by the signal strength, the presence of certain obstacles, and the transmission ranges and the directivity of antenna for both the sender and the receiver. One of the modern networks, the ad hoc networks, are very relevant and of interest here because these networks are deployed at runtime to achieve mission critical application realization. In ad hoc networks versus infrastructure based networks, which are the networks we frequently come across, ad hoc networks have no infrastructure. It means they do not incorporate cabling, network elements, and even configuration by the network administrator. So the wireless nodes are at their own, so they need to transmit the data, receive it themselves also, and relay or forward it on behalf of others. So if ad hoc network, which is a wireless ad hoc network, is deployed in a certain geographical area, it is usually deployed in a random fashion. So the random deployment means that no a priori engineering and design has been invested. So the locations follow a spatial distribution. It means since it is a random distribution in space, the nodes could be cluttered together, the nodes could be highly sparse or thin in deployment. When these nodes are deployed, their primary objective is to establish a network with each other and to communicate. However, they need to communicate with their own transceiver constraints, including especially the transmit power and the receiver sensitivity. Let's look at the illustration now, and then we draw useful conclusions of it. If you look at the figure, it has two parts. The one on the left hand side includes random distribution of wireless ad hoc network nodes, and the transmission range of a reference node, say the node in the middle, to be covering all the nodes in the network. So that is the case which is defined on the top. That is, the transmission range in the network is large. Consequently, what happens is each node is within the range of every other node, and as such, no multi-hop routing or communication scenarios and the associate problems are there. But what is the flip side? The flip side is, since each node is wireless and has certain constrained battery pack, so after a while, the battery is going to deplete. And the overall life of this network with increased maximum transmission power is limited. If we reduce this transmission power, the obvious advantage that we are getting is that the network gets to live longer. And we are also able to use simultaneous transmissions and receptions, also known as spatial usability. For that, we need multi-hop communication because maybe two nodes are not directly within the radio range, so they need to transmit and receive from each other using intermediates or multi-hop communication. In multi-hop communication, the route discovery and even before that, node discovery is an important consideration, and that is what makes it more challenging. In order to assess if two nodes are within the radio range and their connectivity is intact, we have to establish a relationship through a simple mathematical form. For that, let's look at the visualization. Imagine we have two nodes, that is node 1 and node 2. If these nodes are distributed amongst many nodes in a given geographical area in a normal distribution between the range 0 to z, and imagine that x1, that is location of the first node, is closer to is less than or equal to the location of the second node, it means that the node 2 is farther from the reference or starting point of the topology, and node 1 is closer to the origin or starting point of the overall topology. Then these two nodes form a connected network if the difference between these two, x1 minus x2, which is the Euclidean distance difference between the two nodes, is less than the transmission range R. The transmission range R is actually the transmission range of every node Rn, and we can generalize it to be the same for every node in the network. Now, if we look at the graph, we see that the area bounded by origin A and B, OAB triangle, actually determines the maximum distance that x2 can be placed at. The range R has to be more than the difference between x1 and x2, and this is shown by the shaded region. Now, within the shaded region, as long as x1 and x2 assume any value, but their difference stays less than the transmission range, it means the network would stay connected. Otherwise, the network is going to disconnect.